Okay, this recording is for Algebra 1, and this is dilation dilemmas. You need to realize that a dilation is where a picture can get bigger or smaller. If your scale factor is greater than 1, it's going to get bigger. If it's smaller than 1, it's going to get smaller. That's just kind of some background information that you won't really use much. Looking at your notes, you have the sketch. You probably only have the first two pictures. Don't worry about drawing the second two pictures, but we're going to look at mine to get information. If the length is 1, then the area is 1 times 1. If the length is 2, then the area is 2 times 2, which is 4. So the next picture would have a length of 3, which would make for an area of 9. And the last one would have a length of 4, which would give you an area of 16. So make sure you have your table filled out. What is the independent and dependent variable in the situation? This is making you think back to several weeks, maybe several months ago. We learned that when they ask for independent and dependent, they want words, okay, not numbers. Independent is whatever the x is. It's what's in the problem. So if I look back at my table, this figure number really doesn't count for this table. Here's my x, here's my y. It's always going to be in that order on the table. So what are the words that x stands for? Length of dimension. So your independent is your length, which means that your dependent's the y, which is the other, which if you look at your table is going to be area. It's always looking for words here. Okay, the next one wants you to give a reasonable domain and range for this situation. Domain and range wants numbers. So domain is talking about x. If I look at my table, the x values are 1, 2, 3, and 4. So your domain is 1, 2, 3, and 4. Your range are the y values, and so it's 1, 4, 9, and 16. You're going to use the domain and range values to set the window on your calculator. There is a button at the top that says window. When you set the window, you're just choosing what you're going to see when you look at the graph. Your x is talking about domain. You want it to be a little smaller than the domain ever was to a little bigger than it ever was. So my smallest number in domain was 1, so my x min is going to be 0, just a little smaller. My biggest number in my domain was 4, so I'm going to go up to 5. X scale is how it's counting, what your hash marks are going to be. Just going to 5, you may as well count by ones. Your y min, your smallest number, was 1, so let's start at 0. Your y max, your range's biggest number, was 16. We need to go a little bigger. You could go to 17, you could go to 20. X scale, going to 17, I think you could still go by ones. If you wanted to, you could go by twos. We won't mess with the X resolution. Now, if your Y max had been something like 150, you would not want to count by ones or twos. You would probably want to have a Y scale of 10 if you were going from 0 to 150. Okay, this does not have to be written on your notes. I'm just explaining. You need to be aware of that when you do the assignment. Okay, draw a scatter plot labeling your axes. The horizontal is x, so you go back and see what was my x talking about, and that was length. And then your y is your range. What was your y talking about or your range talking about? And that was area. Then you just plot the points. Scatter plot wants points. So you went over 1, up 1. You went over 2, up 4. You went over 3, up 9. You went over 4, up 16. Doesn't have to look exactly like this, but kind of. We put this in our calculator. To go to your calculator, to get it in your calculator, let me clear the ink off of this. You go to Stat. If I could just type. You go to Stat, Edit, and at L1, you're going to put your X values, 1, 2, 3, 4. At L2, you're going to put your Y values, 1, 4, 9, 16. Then you're going to go second, stat plot. That stat plot is up there. It's the Y equal button, actually. And you're going to press enter. so that you're looking at stat plot 1, you want to go to on and press enter, and you want to make sure that it's looking at L1 and L2. Having done that, you could press your graph and you would be able to see the points that made up your graph, and you would know that it did indeed look kind of like what we had drawn. So which parent function models this data and why? If you look back at your graph and you had it like this, okay, think of it as if I connected it. If I just drew a line, straight line, would it hit all the dots? No, so it's not linear. But if I connect my dots, see how I have a curve? And if I were creative and extended the curve and did like that, does that not look like a parabola? So your answer is quadratic because it forms the shape of a parabola. Would this data be discrete or continuous? Got to think way back again. Discrete means that you can't have part of something. Continuous, you can have part. We are talking about, if you go all the way back and look, we're talking about these squares. And as we added it, we added an entire square at a time. You could not add part of a square. That means that this data is going to be discrete. So you had to use your calculator. What we did was we took the top for this part right here, just came from the same table on the first page. Okay? Then we added it. We went on to 5, 6, and 7. We squared them. So that's how you fill in the table. Take a minute, get that filled in. Then we found what we call the first difference. To get the first difference, we said 4 minus 1, and we got 3. 9 minus 4 gave us 5. 16 minus 9 is 7. 25 minus 16 is 9. 36 minus 25 is 11. And 49 minus 36 is 13. That's your first difference. Okay? The second difference is where you subtract the numbers that you just wrote. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. 13 minus 11 is 2. Okay? So then they want you to look at this and see, is it linear or not? Well, we've already said it's not because of the way the graph looks. The other reason we know it's not is that your first difference is not the same. So first difference must be same to be linear. You would have had to have the same number going all the way up and down here for it to be linear. We didn't, so it's not. So it told you to compute the first difference. We did. Is it constant? No, it was a different number every time. So then we found the second difference. Was it constant? Yes, it was always 2. Since the second difference is constant, the graph is quadratic. That's the rule. So what parent function? What is the parent function for the linear function? Y equal x. The parent function for the quadratic is y equal x squared. If you went back to your calculator and went to y equal and put in x squared, and then looked at your graph where you had your dots, you should have a line draw that connects your dots. Okay? You don't have to write all this stuff down. I just want you to understand it. Maybe look at your calculator. So using your new parent function, which was y equal x squared, predict the area for the following lengths. You would just go to your table, see where x was 10, where x was 15, where x was 30. Would it be possible to have an area of 290? No, it does not show on the table. So it's not going to be possible. The reason is that it's not a perfect square. Once again, you don't have to write what they had. So this was Dilation Dilemma for Algebra 1. If you have questions, come see me during speed.